Hi everyone, it's my 8th day in Taiwan. We plan to visit Taipei Astronomical Museum. This museum is huge. It got 3 stories, so I will show you what each stories look like. As you can see, the 8 planets are on top of your head and a large screen that shows all the planets, stars, pulsars, and exoplanets. In the start of first story, it has a model of the moon's surface and the first person landed on the moon, Neil Armstrong, on 21st of July 1996. The board there below shows Japan had a plan as well. In 2030s, they plan to have astronauts to be land on the moon as well. This pathway summarized many types of rockets and transportations. Now let's go inside a simulated space capsule to see and explore astronauts' lives. That's the lavatory. That's what they eat. I am not too sure about the spark chamber, but I'm pretty sure it uses for how aurora are created. That place there informed solar wind. This was summarized auroras, space weathers, solar winds, and how long the solar wind take to Earth. That's a simulated capsule for rockets. That machine is literally uses for Newton's third law. As you press the buttons, you are able to see the effects. That's called action and reaction forces. These are the rockets that America, Soviet Union, China, India, and Japan have used. That machine showed global warming. That's the simulated cyclones. That's the model of Earth. As you can see the rotations if you press the tablet. That's the Earth's layers. And the magnetic field. An image shows the structure of Earth. At the start of second story, it has 2 little rooms, one's for outer planets and the other one's for inner planets. It clearly shows all the planets and its natural satellites. That's Jupiter's giant spot. It's also a cyclone. Before it used to fit 3 Earths, but after it shrinks, right now it could only fit 1 Earth and a natural satellite or maybe a inner planet. These are the inner natural satellites of Jupiter. These are called Io, Europa, Ganymede, and Callisto. They were discovered by Galileo Galilei. That's the second largest natural satellite in the solar system, called Titan. It's the 6th natural satellite of Saturn. That's the second natural satellite of Saturn. is called Enceladus. It has many cryovolcanoes on its surface and an ocean under the crust. That's the summary of planet Uranus. The most important thing that I would like to talk about was the reason why Uranus rotates backward and rotates while it's lying like a naughty boy, as I said 2 years ago on my vlog. That's the fifth natural satellite of Uranus called Miranda. Now that's the summary of planet Neptune. The inside view of planet Neptune is literally so pretty. That's the surface picture of the natural satellite called Triton. It's the largest natural satellite of Neptune. This wall is covered by the star clusters and nebulas that the astronomer called Charles Messier has discovered. If you don't know him, you can have a watch my previous vlog. How nebulae and star clusters differ toward each others. All the nebulae and star clusters he discovered look so gorgeous. Do you know what's in the center of Milky Way galaxy? Have a read. Yes, that's how the four seasons, the big seasons created. So our solar system is rotating the two black holes. These are the many types of lights from all the stars. That shows the structure of Milky Way galaxy. Pause the video and have a read the information. That helps you to know what black holes are if you press the button. Black holes are created by massive stars such as Rigel and Betelgeuse after the explosion of neutron stars. The process first begins with a supernova. See what an object looks like if it gets close to the black hole. It's called spaghettification, as the black hole uses its strong magnetic field to pull the object into a long and thin shape like a spaghetti. Compact objects are space objects. They are small in size but massive in mass, like neutron stars, white dwarf stars. Sirius B is slightly smaller than Earth but slightly larger than Venus. This diagram showed different temperatures of different types of stars, such as blue giants. Blue giants got higher temperatures. Main-sequence stars, yellow dwarf stars like our Sun, got middle, a bit lower temperature. These are red supergiants. And white dwarfs and brown dwarfs, they both got lower temperatures. That's what the inside of Sun looks like. The stellar sizes comparison. The size of the Sun compared to planets, inner planets, and outer planets. These are called black spots. That's the Sun in multi-wavelengths. It changes into multiple colors as in different wavelengths. These are the meteorites. The reason why it got a layer of glass on top of it is to make sure to avoid radioactivity. This one definitely doesn't have any radioactivities because you can touch it with your hand. Well, I don't think all the meteorites got radioactivities. If they have, how can they be in the exhibition? That's the largest meteorite. This machine shows how craters created. As you know, the little ball can be identified as a piece of meteorite. Imagine I am rotating on an orbit right now. These places are the orbits of the 8 planets. They made the surface look very realistic. They made these planets extra realistic, but these planets are actually devices that describe theories about themselves. That's my favorite planet, Neptune. As you point at the tablet, you are able to see many informations of the planet. Some of them are very interesting. These transportations below can tell you how long does it take to get there. So imagine if we ride a bike. First data is hours, second data is days, and third data is years. How about by a car? Let's see. So the same, first hours, second days, third years. By plane, it takes rocket is the easiest choice. It doesn't take that long. Well, it still takes 11 years, but it's not that crazy like others. That's the structure of the planet. If you don't know that, that's Neptune's giant black spot. That's the appearance of it. It also tells you a little bit of history of why ancient people named it Neptune. It tells you a few ancient stories as well. That shows your weight. That's the formation of solar system. Right now, solar system is 4.6 billion years old. how solar and lunar eclipses work. These are the constellations with their pictures that showed how each constellation looks like a specific thing. Those are just the Messier diagrams of those constellations which are clustered together. This screen shows the position of constellations as you rotate this to see where they were going to be in different seasons. There's a globe inside and constellations outside. It shows what constellations you can see as the Earth is rotating. Before we leave second story, we are going to explore inner planets. The journey begins from the Earth. We are going to our sister planet, which is Venus. This is not the real surface of Venus because it has a very thick atmosphere that creates the greenhouse effect. The temperature on the planet is hot as 500 degrees Celsius because its atmosphere is 90 times thicker than our atmosphere. By the way, that's what the surface of Venus looks like. It's scary, right? We're going to Mars right now, the second closest planet to our Earth. It's half the Earth's radius as it says. There's also a lot of craters on Mars' surface. That's Olympus Mons, the tallest mountain or the tallest volcano in our solar system. These are the ice on Mars. Mars has very strong storms that create these patterns on the surface. That's the first natural satellite of Mars, called Phobos. Originally, Mars got two natural satellites. The natural satellite on the left side is called Deimos. It was discovered by an astronomer called Asaph Hall. The start of third story showed the exoplanets that have currently discovered. The third story mostly describes telescopes and man-made satellites. In other words, technologies mostly. If you press the tablet, it gives you information of it. I just picked James Webb Space Telescope. This area here has a lot of things that ancient people used to discover planets and stars. These simulated man-made satellite machines shows how the signal travels through this place to another place. Do you guys remember an astronomer called Nicholas Copernicus? He was the one that got burnt for saying the center is sun and said Earth rotates around the sun, not sun rotates around the Earth. These are the star systems like the solar system. Those are the results by Hubble Space Telescope. That's how gravitational lensing works. As you change the direction of the magnifier, it changes the shape of each space object like a black hole. The center of it, I mean. So lucky I recorded that one. So that's the Milky Way and Andromeda Galaxy collide to create Milky Way galaxy in the future. This part can be the formation of Milky Way galaxy then. We're inside the theater right now. It's next to the exhibition hall. You can see there's a golden ball if you go outside to have a look at the museum. So that's where we are right now. We're looking at a long universal journey, and it's a giant screen on top of our head. It's like a globe. I hope you enjoy watching the journey. Right now, we are already flew to the outside of Milky Way galaxy. That's where our Earth is on the Milky Way galaxy. That's when all the galaxies are clustered together.